Interval notation is a way in which we mathematically write a region of values. For example, on a number line, we start with 0, and we notice that this arrow continues to our right. In fact, that never stops. If I think of a larger number, you can always think of one larger than that. So we say that it heads toward this positive infinity. Now, when you type answers into WebWork, you may have to type in infinity. It's a sideways 8, which isn't on the keyboard, so you actually type infinity. Be sure to look at the directions. Heading to the left, we see that this arrow continues to my left, so we call that negative infinity. And so we're going to start to show a region of values, and I need to know, do I want to include that value or not? If there's a bracket in that interval, that means that you are going to include the value. And if there is a parentheses, that means to not include the value. So let's go ahead and take a look at a couple examples here. If I have what we call a parabola, you haven't really heard of this word yet, but we'll be studying it always here along chapter 8. If I look at that parabola and I want to tell you about the x's, and I want to know where is this in the x increasing? Where is my function increasing? Well, as I read left to right, I look, where is my graph increasing? And it looks like my graph is rising or increasing right in this region. And notice this graph would continually open up. So it's increasing from negative infinity, always from the left, to the right. And it looks like it reaches this point up here, which is 2 on the x-axis. Now, we're not going to include 2. It increases all the way to 2. So this is a ball or something I'm throwing up, a projectile, I'm throwing it up in the air. It is going up until it hits this point right here. Then it stops for just an instant. So the slope is 0. So it's no longer increasing or decreasing because 0 is the divider between positive and negative, and it has no sign. It's neither positive nor negative. So at that point, when it hits the top or 0, it stops. We do not include 2. Now, if I'm looking where this function is decreasing or headed downward, it's headed downward from that point 2 all the way. So from negative 2 to infinity. Now notice I don't include infinity because infinity is not a number. Infinity is not a number. Infinity is kind of a location. It's way out there, and you can always continue to grow or get further out. So it never, ever stops. So let's look at a graph that goes to negative 2. So it's heading into negative 2. Then it stays with no slope. And then it heads out at 1. So if I look at this graph, and I'm looking for this where this graph is increasing. So I'm moving along this graph left to right. I'm increasing along this edge of it. Just this piece of this graph. And that piece starts at 1 and goes to infinity. Notice neither of those two are included. And I am decreasing when I'm headed down, and that's in this direction. So negative infinity on my left, and I'm reading all the way to negative 2. Now in the center here, it's neither increasing nor decreasing. In fact, the slope is equal to 0. And if you recall, 0 is neither increasing nor decreasing. It doesn't have a sign on it.